So what we hopefully know, this is now in factored form because that has been factored. This one is not, so we're going to have to do that first on that one. So we know the period, the natural period for a sine and a cosine is 2 pi. We're in radians here, so there's no degree bubble. And so the natural period is 2 pi, and we're going to divide that by what we're calling b. So we kind of have assigned letters to these things that describe what the different transformations are. So the b is going to be the horizontal stretch or shrink. In this case, it's going to shrink it because it's bigger than 1. So to get the period of this graph, we're always going to start with the natural period 2 pi and divide it by whatever is multiplying dx. And so that's going to make that into pi. So we're going to complete one full cycle of a sine curve in a horizontal distance of pi. Now this is a Mr. Street made up name, but we want to put our tick marks every fourth of a period. And so I'm calling those critical points, but nobody else besides me calls them that. It just hasn't caught on yet. So we're going to take the period that we ended up with, divide it by 4, and that's where we're going to have the spacing between our tick marks. So now we can start to see what our graph is going to look like. Now the D here, what's being added or subtracted is our translation vertically. So everything is going to get moved up 1. Now without that, our sine curve would wrap around the x-axis. That is, we would say the midline would be y equals 0. But that's going to get moved up to 1. So I'm just going to put, you don't have to do this, but I think it helps kind of sort things out, especially when you're starting, to put a horizontal line there. This is going to be our midline, so our curve is going to wrap around that. The amplitude is going to be the absolute value of that A, and that's positive already. So our amplitude is going to be 2. So since the biggest a sine can ever be is 1 or negative 1, that's going to get multiplied by 2. So that's going to stretch our graph vertically by 2. Instead of just going from negative 1 to 1, it would go from negative 2 to 2, except it's been translated. So the tallest our graph will ever be is 2 up from there. I'm going to put a dotted line just to use as a guide there. And then I'm going to go down 2, which is going to put us at negative 1. So our graph is going to wrap around that y equals 1, reaching at sometimes the highest point at 3 and sometimes the lowest point at negative 1. Is that okay so far? So then I'm going to start the tick marks. Well, this has been factored, so the pi over 6 is the translation horizontally. So our graph is going to, which would normally start at the origin for a parent function sine curve, is going to start at pi over 6. So I'm going to go over and I'm going to call that pi over 6. Now my tick marks are going to be spaced by this fourth of a period. So we're going to add pi over 4 to the pi over 6, and that'll be the next tick mark. That means we're going to have to do some work with adding fractions. So we need a common denominator of 12. So this is 2 twelfths, and our pi over 4 is going to be 3 twelfths that we're going to add to that. So our next tick mark, now pi over 4 is a little bit bigger than pi over 6. So I'm going to go and just call that is going to be our 5 pi over 12. That make sense? Then I'm going to add another pi over 4, which is another 3 twelfths, to the 5 twelfths to get the next tick mark. And so that's going to be 8 twelfths, and you're free to leave it as 8 twelfths, but I kind of feel obligated as a math teacher to reduce that, which I think 8 twelfths will be 2/3 pi. Then the 8 twelfths plus another 3 twelfths, the next one, is going to be then at 11 twelfths, which is going to be 11 pi over 12. We're every fourth of a period, but we're also putting the starting place. So I need a total of 5 labeled here to get one full period. So I'm going to go one more. Adding 3 twelfths to the 11 twelfths is 14 twelfths, which I think is 7 pi over 6. Sound right? Okay. All right so far. Now, our actual graph is going to be a sine curve, so it's going to start in the middle. So we're going to have a point right there at pi over 6, 1. Then the normal sine curve is going to do a loop above first. So from the middle, I'm going to go to a high point, back to the middle, to a low point, and finish back at the middle again. And then we'll connect that with a nice smooth curve. And there is one period or one cycle of that sine curve. Does that make sense? Okay. Let's try, we'll do this one together, and then we're going to try coming to the board and do some of these graphing ones. I'll give you another round of them. Okay, so I'll leave that up there for a moment. Let's see if we can duplicate what we did there. So here, because it has not been factored, that's the first thing we have to do. So we're going to factor out whatever is in front of the x, because we want its coefficient to be 1. When we do that, this pi over 4 is going to become 1. Okay, so now we can see, separated out, the horizontal stretch or shrink from the translation horizontally. So our period is going to be, as always, the natural period, which if we're in radians is 2 pi. If it was degrees, it'd be 360, divided by the b, the thing that is multiplying the x. So to divide by pi over 4 is to multiply by the reciprocal. So the pi's will cancel, and we're going to get just 8 for our period. So our critical points, which is going to be the spacing between our tick marks, is going to be period divided by 4, so that's going to be 2. Okay? So since we're going to start at, the translation here is going to be a -1, so we're going to go -1, and then our spacing is going to be every 2. So if I add 2 to that, that'll put us at 1, and then adding 2 to that will put us at 3, and then 5, and then 7, and that's 1, 2, 3, 4, 5, so I've got enough for one full period. Is that okay? So our translation vertically on this one is going to be 2. So I'm going to put a dotted line at 2. That's going to be the middle of our graph. So that's our midline. Then the amplitude here, is it my camera or is that somebody's phone? Oh, that's okay. I thought something was going wrong here. So our amplitude here is going to be the absolute value of the -3. So the amplitude is 3. So we're going to go 3 up from the 2. So extend that a bit. 3, 4, that's going to be at 5. There's going to be the top of our graph. And then going down 3 from the midline will put us at -1. That's going to be the bottom of our graph. And then the cosine normally starts big at a high point. But because this is a negative, it's been reflected in the x-axis. So instead of starting big, it's going to start small at the lowest point. So at -1, we're going to be down at -1. So -1, -1 is going to be the first point in our cosine curve. Then the next critical point will go to the middle, over a critical point up to the highest point, over a critical point to the middle, over a critical point to the lowest, and remember that's below the x-axis, yes.
Would this be like considered like a bell curve that you would use to curve a grade?
Actually, those are different. I mean, it might be a little suggestive of that because it does, this one period does look kind of like a bell. I think that we would agree that's kind of bell-shaped. An actual bell curve has comes from e to the -x squared is its parent function.
Oh, okay.
Because it will have actually a horizontal asymptote at the x-axis. It's going to approach the x-axis there.
Mm-hmm.
And then you have to doctor it up so that if you're using stats or something.
No.
Oh, well, you live and die with this in stats. This is where normal curves come from and all the normal distributions. So we talk about that a little bit in calculus, more in BC Calc. Okay, this is all right, and that goes on and on and on forever. Okay, so let's try one. I'm going to give you another one. You can come up to the board and do this one. So see if we can graph. Y equals, we'll say -3 sine of, say, pi over 8x minus pi over 4 plus 1. Jeremy, did I give you a worksheet? Do you want one?
No, I haven't.
Do you have one at home? I'm going to give you one just because in a minute we're going to do some of these together. Because we're going to put them in the graph. Might be nice just to have one to look at. Somebody else not have one of those worksheets? Did I miss anybody? Pause this while we're working. We'll pause the camera while everybody's working, then we'll come back. So we have, when we factor out the pi over 8, because we want to make the coefficient of x be 1, this becomes an x minus 2. So our period is going to be 2 pi divided by the pi over 8, which is going to be 16. That's going to make our tick marks be every 4. So our curve is going to be translated up 1. So that's going to be the midline. Our amplitude is the absolute value of -3 is 3. So that's going to take us up to 4 and down to -2 for the low point. We are going to start at 2. So 2 is going to be our starting point. Our critical points are going to be every 4. So that's going to put us at 6, at 10, at 14, and for one full period, we'll have to go all the way to 18. So we will start with a sine curve in the middle, which for us is going to be at 2, 1. Because it's a negative sine curve, it's going to get reflected. So we're going to go to a low, back to the middle, to a high, back to the middle. And we're going to get our loop below and loop above. So there is our sine curve. Okay, let's do one with a cosine. So y is equal to, we'll say 2 cosine of, and let's say 2x minus, we'll say pi over, say 2 minus 1. Okay. People that weren't up at the board can come do this one at the board. And I'm going to pause the video again. So if you're watching it, you might want to pause it and give it a try yourself. Okay, so we are going to factor out the 2, and that's going to make that be a minus pi over 4. So our period is going to be 2 pi divided by that 2 is pi. That means our tick marks are going to be spaced every pi over 4. So our graph is translated down 1. That's going to be our midline. The amplitude is going to be 2. So we're going to go 2 up and 2 down from our midline. So we're going to be at 1 and -3 for the high and low. So at pi over 4, there's our first tick mark is going to be pi over 4. We're going to add pi over 4 to that, which is 2 pi over 4. And you're fine to call it 2 pi over 4. That isn't really a big deal with me. As a math teacher, I feel obligated to reduce, but I won't certainly judge you based on that. So there's our tick marks. And a cosine is going to start big. So at our pi over 4, we're going to be at a high point. then over to the next tick mark to go to the middle. The next tick mark takes us to a low point, back to the middle, and we're going to finish high again. And so we get, there is a one period or one cycle of a cosine curve. Okay, well, I want to go and talk about some new stuff. We can come back to this and some other stuff if we get time. Looking ahead a little bit, this is going to be like death by testing here. So we're going to be ready for a test this Friday. Then we'll do kind of a semester final, because we will have finished this kind of advanced algebra or algebra 3 stuff. And we're going to take that the following week. Then I think it looks like we're even going to be able to squeeze in the next test just on the trig stuff, which will then maybe be on that December 18th, that Friday before vacation. So we'll go out of 2020 with a bang here and go test, test, test. Okay, so let's talk about finding equation from a graph. Find an equation from a graph. So we've been doing here's an equation of a sine or a cosine. You come up with the graph. What we're going to do is just the reverse. We're going to look at a graph, and we're going to try to come up with an equation that matches that graph. Now, we know that sines and cosines are translations of each other. So an equation that we get is not unique. In fact, for any particular curve, we can come up with, given the right information, an infinite number of equations for that. So a curve like this, for example, we could say starts big, which would make it a cosine curve starting here at this x value. We could also think of it as a cosine curve where it starts here at this value, or the next peak, or the next one, or the one before that. So we could come up with any number of positive cosine equations that would have this curve. If we thought of it as starting at a low point, we could consider this correctly to be a negative cosine curve, or the next low point, or the one over there, or the one there. So we could come up with an infinite number of equations that were negative cosine curves that would match this. We could think of this as a sine curve if we started at a place that was in the middle, and what came to the right of it was going to be a loop above. That would make this be a positive sine curve. If we start at a place in the middle and immediately to the right of that is a loop below, that would be a negative sine curve. And so part of what we're going to talk about is, we're going to try to recognize what the choices are. When I ask you this question on a homework problem or a quiz problem or a test problem, then I'm just going to ask you to come up with an equation. Okay? But when I do the answer key, then I got to figure out all the ones that are correct and make sure that any one you come up with is okay. Okay, so I don't care which one you come up with as long as it is a correct version of that. So to do that, I'm going to ask you to pull out that worksheet that we did from Tuesday, and because it's got some nice graphs on there, and we'll do a couple of these together. So if you look at the back side of that number 9, we can go ahead and let's do number 9 together here. Now, the only thing that I would caution you here as you look, because where I found these examples, and I know they're not terribly clear there, but I think all but one of them are in degrees, which is not really my preference. I want you to be able to do this both if the angles, when you look on that x-axis, if the tick marks are in degrees, then that means we're going to have to treat the natural period as 360 degrees. Whereas if you don't see any degree bubble, then that means it's going to be in radians, and our natural period is going to be 2 pi. So that's going to affect how we decide what the b is. So remember, we're looking for something that's going to be a, either a sine or a cosine, b times x minus c plus d. And so I guess I'll write it in both of those ways. So what we are going to try to figure out is what's the A, the B, the C, and the D. We'll have to decide early on, is it going to be, are we going to think of this as being a sine or a cosine? Sometimes it won't matter, it's just a matter of your personal preference. Other times, because of the information given, it may be easier to do one than the other, and so we'll try to talk about that. So we're just going to, when we start out, we're going to agree what we're going to do so we can get the same thing and do it together. But then we'll talk about what other variations or other correct answers of that could be. So when you look at that first curve, if you were going to think of that as a positive cosine curve, then what could be a starting value, a starting x value? Where could you think of that positive cosine curve starting?
24, 18.
24 and negative 18. You with me there? I need nods of heads. So you're looking for a high point because the cosine is going to start big. So you pick one of the peaks there, and when you come down and you read the x-axis there, that you could have either the negative 16 or a positive 24. If you wanted to think of that as a negative cosine curve, somebody other than Ronan, tell us, what could your starting value be?
4.
Good. You see that? So a negative cosine would start low. So we could correctly choose either the 4 or the 44. If you wanted to think of this as a positive sine curve, somebody other than Ashlyn and Ronan, where could this thing start? Now, a positive sine curve is going to start in the middle, and when you look immediately to the right, it's going to have to go to a loop above. So a positive sine curve could start where?
14.
Or?
54.
Yeah, either 14 or 54 could be a positive sine curve. And then finally, which one or ones could be a negative sine curve? That is, you would have to think of it as starting in the middle and then followed immediately to the right by a loop below. So where would a negative sine curve start on this one?
-6 or 34.
Exactly. Does that make sense? Okay, so so we do it the same, on this one. It won't matter when you do them after this, but just so we can agree on this. Do you want to think of it, you can choose. Where do you want to think of this as starting, Claire?
24.
24. So if we're going to start it at 24, that means we're going to think of this as being a what? Positive or negative sine or cosine? Positive cosine. So we're going to think of this as a positive. It's going to be a cosine. We're going to talk about the A in a minute. We'll come to the B. That's always the hardest part. And then because we've decided it's going to start at 24, we're going to start with an x minus 24 degrees, and we'll still figure out what the D is. So this is what we've agreed on so far, is it's going to be a positive cosine, and it's starting at 24 degrees. Okay, let's figure out the amplitude next. I think that's pretty easy. And the order we do this in now doesn't make any difference. Okay, just the first thing is you got to decide, is it going to be a sine or cosine, positive or negative, or are you going to start it? After that, the order doesn't make any difference. But I think amplitude is generally not too hard to find. Remember, amplitude is going to give us that A, and we want the maximum minus the minimum divided by 2. So the amplitude, or RA, is going to be the maximum y value minus the minimum y value divided by 2. And so for us here, what is that going to be? What's the maximum it's going to be? 18. And what's the smallest it's going to be? And so that's going to be 10. So we're going to put a 10 here. That's how we're coming up with the A. Is that okay? Now, once we know the amplitude, finding that D, the vertical translation, we can either start with a low point and add the amplitude to that, or start with a high point and subtract the amplitude from there. And so that's going to make that midline, that translation, our value of D is going to be how much? 8. See how we got that? Okay, so that's going to be a plus 8. So now that leaves us with always what the hardest one to find is the B. So here's the idea. We know that if we were graphing this and it's in degrees and we had whatever equation, we would say the period is going to be the natural period, which in degrees would be 360, divided by the b. Does that make sense? So if we were going to solve this, we could multiply the b over to the other side. So we would get b times the actual period would be 360 degrees. You with me there? Solving now for the b, we would divide the period to the other side. So what we're going to see is that to figure out what the b is, we're going to take the natural period, which you got to be careful. Is it degrees or radians? Because that will make a huge difference. In degrees, it's going to be 360, but in radians, it's going to be 2 pi. You're going to have to figure out what that period is, and when we divide those two, that is going to give us our number b. Making sense? Now, how do you decide what the period is?
You look at two of the same points in the curve.
Exactly. So you can look at what is that horizontal distance from one peak to the next, from one bottom of the valley to the next, or from two middle points, but make sure that you get a loop above and loop below in between those. So you can take the x values that you find and take the right one minus the left one, and that is going to be our period. So, Grace, which do you want to go peak to peak or middle to middle or valley to valley? What are you seeing? Middle to middle. And so what's the right one that you want to use?
14.
And what's the left one? Now 14 for the right one's going to be tough because we don't really have. How about pick a different one?
So it would be 14 for the left and 54 for the right.
Okay, so 54 and 14 would work. You could also go peak to peak. And so that is going to be 40. So just, and it doesn't make I'm not terribly concerned about the units here, but just so you see, this B is going to be 360 degrees. The period is also in degrees. Those degrees would cancel. So our B is going to be unitless. So the only place you would see the degree in this equation is going to be in that translation part. And if this was radians, you wouldn't see any units anywhere because the translation in radians is unitless, does not have units. So we're going to put the 9 there, and there we have it. Okay, now, just so we can clarify, can you come up with a negative cosine curve for this an equation that has a negative cosine for this very same graph? And Isabel is nodding her head yes. So Isabel, tell us one possible negative cosine curve, cosine equation for this same curve.
Would it just be negative 10 cosine of 9 times x minus 4?
Yeah, so you have a choice. You chose 4, which is correct, or you could also have chosen 44. So either of those would have been a negative cosine. So can you come up with a positive sine curve? An equation that has a positive sign for this very same thing. Jeremy?
So it would be 10 sine of x minus.
Not yet.
Oh, 10, okay, yeah, 10 sine 9.
9.
And x minus 14.
Good. What other choice could you have used and there's still the plus 8? You could also, besides the 14, have used 54 would have been correct as well. Okay? And how about a negative sine curve? Ashley?
Negative 10 sine 9x minus 34.
Good. And you could, yeah, we could also have used what?
Negative 6.
So it would have been an extra plus 6 on that one. Great. Does that make sense? Okay, I think, let's go ahead and just go across and do number 10. Okay, see, anybody want to try to do it at the board? Are we comfortable enough to try it at the board or no? Okay, so if you have that level of confidence, come on and try it at the board. And if not, you can stay at your desk. But either way, do collaborate and compare the answer that you're getting with somebody next to you. I'm going to pause the video for a moment.
He's going above the
He's an overachiever. You'll love that.
I don't know what the last one was because I don't know how to add 65 and 180.
That higher level math, the addition part that's throwing you there. So I think we are agreeing that we have an amplitude of 6. And if you thought of it as a positive sine curve, either way, your B is going to be a positive 2 because our period was 180 degrees. So B is the 360 divided by 180. You could do a positive sine curve starting at 25, and your midline, that translation vertically, is going to be 9. And then we have also there a positive cosine, I see on the backboard, is going to start at, now positive cosine is going to have to start to minus 20 degrees, I think, is one possibility anyway. We could also have had a positive sign starting at 200. So you could also have had a minus 200. You could have a positive sine curve that also started at 155 degrees. So that could have been an x minus 155. Did anybody do a negative sine or a negative cosine? Anybody get anything any different than this? Because you could have also done it that way. Okay. Questions on that? Questions on the homework? Okay, shall we talk about, we've got, I guess, 3 minutes. So let's see if we can, I meant to give you a quiz today and I forgot. So let's make sure we know some of these. So I think probably tomorrow there'll be a quiz on these, and you guys will probably see a quiz on this more like on Wednesday.
I am so glad that you forgot about it.
So let's see if we can, without the aid of a chart or notes, if you can. If not, you can refer. But when you take the quiz, you're not going to have any notes or a chart or anything. You have to know this from memory. You want to do it together, or you want to try to see if you can figure it out? Okay, so what we're trying to do is visualize quadrant 1. So in quadrant 1, you know that there's halfway, and then you're going to have these two there. So in degrees, these would be 0 degrees, this would be 30 degrees, this would be 45 degrees, this would be 60 degrees, this would be 90 degrees. Now in radians, this would be 0 radians, this is 1/6, 1/4, 1/3, 1/2. Okay, so it's the order that really matters. I mean, you have to remember the actual numbers and then their order. Now sine, you remember, is going to be the y values. So sine is going to start small. The 5 values that we need to know in order from smallest to largest is 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Those 5 numbers. So the thinking for sine of pi over 6 is you go 0 pi over 6 is 1 click. Sine starts small, so it goes 0, 1/2. So the sine of pi over 6 is going to be 1/2. 2 pi over 3, you're going to have to be able to put into quadrant 2, and we want the reference angle. Since this is 3/3 minus 2/3, this would be 1/3 pi, which is pi over 3. Okay? That's putting us back in quadrant 1. So we go 0, pi over 6, pi over 4, pi over 3. Cosine starts big, it goes 1, square root of 3 over 2, square root of 2 over 2, 1/2. But in quadrant 2, cosine is negative, so that would be a negative 1/2. Practice, practice, practice. I see quizzes on these coming up.